Let's see this question. We want to find all the characteristics of this rational function, then to be able to sketch a graph for it. So let's first try to see if we can simplify this. The numerator we can factor out 3. Then we have x plus 4, 2 factors. Denominator we can factor out as a 4 because 16 is 4 squared, difference of 2 squares. We can factor out as a 4 minus x and a 4 plus x. So we have common factors in the numerator and in the denominator. Okay, so factor, same factor, so that cancel out to be 1. So the function can be simplified as a 3 over 4 minus x. Okay, now let's try to find vertical asymptotes. So vertical asymptotes is obvious, x equals to 4, right? When x equals to 4, so 4 minus 4 causes 0 in the denominator. So that means a 4 is not in the domain of this function. So the vertical asymptotes, let's say this is a 4. Vertical asymptotes indicates the value of 4. So the graph never cross the value, this line, x equals to 4 line. Either survives on this side or survives on this side. So then, so x plus 4 is not a vertical asymptote because of the simplification. But however, x cannot, so x not equal to 4 from here in the beginning, negative 4. So this tells us x cannot be negative 4 either. So negative 4, this is a negative 4. So when x is a negative 4, so f of negative 4, after simplification, we use this function to evaluate. Get 3 divided by 4 minus negative 4 becomes 4 plus 4. So get a 3 over 8. So we have something called a removable singularity. Right? Removable singularity is x value equals to negative 4, which is a point. And the function value is a 3 over 8. So x is negative 4 and the y value 3 over 8. Let's see, this is a 3 over 8. So that's this point. That's O. We cannot make a solid. We have to make an open circle. So to indicate this is removable singularity, right? Which negative 4 is not in the domain and the 3 over 8 is not in the range of this function. So if the graph goes through here, it will be like this, right? So this void means this void make these two pieces of, so make this graph like 2 parts, one on the left and one on the right. Let's remove a singularity. Let's see horizontal asymptotes. So horizontal asymptotes, which means we take the limit, then we let x run to infinity. So let's see, if x goes to infinity, we see this value in the denominator. Remember, when we take a limit, when x goes to infinity, we can use ignore rule, right? So we could see this value approaches to 0. So the rule of thumb is if the degree of the denominator is greater than the degree of the numerator, so the horizontal asymptote is y equals 0. You see, in this case, the degree of the denominator is 2, right? Polynomial of degree 2. And the degree of the numerator is polynomial of the degree 1. So the horizontal asymptote is y equals 0, which is the x-axis. The x-axis has another name, which is y value equals 0. So which means the graph will never come across this x-axis, right? Either above or down below. Now let's find x-intercept. X-intercept means the function value is 0. Well, we see this function value will never be 0. So this will never be 0. So that means we have no x-intercept. Right, no x-intercept. About y-intercept. Y-intercept means x value is 0. If x value is 0, we have 3 over 4. So 0 and 3 over 4. So this is a 3 over 8. 3 over 4 will double this. So this is a 3 over 4. Right? So this is our y-intercept. So which means our graph looks like this. So because y equals 0 or the x-axis is horizontal asymptotes, that means our graph goes, let's use black color, gets closer and closer to x-axis, or y equals 0, but we'll never touch it. And then this is open circle, remove a singularity. Then this side goes across this y-intercept. Right? But then it goes closer and closer to this vertical asymptotes, but we'll never touch it. We'll never touch the vertical asymptotes. So this is one. So this is one side of the graph. And then we could try a couple of points, but by the characteristics of rational functions, so we know another piece is somewhere here, survives in this corner. Let's give couple values. Let's see let's evaluate f of 5. Right? That would be 3 divided by 4 minus 5, which is a negative 3. So 5, so let's see, this is a 4, 2, 1. So 5 is somewhere here. And then the function value would be negative 3. So that's 3 over 4. So it would be 4 times. So down below here. We make the 4 of this. 1, 2, 3, 4. Let's see somewhere here. So you see, so one value is here. So the graph survives. Oh, there's y-intercept. No, it's here. It is here. It is here. Oh no, we did a 5. Yes, it is there. It's not a y-intercept. We did a y-intercept already. So that's it. This is negative 3. So we have 5 comma negative 3. Right, so this is 1 point at 5 comma negative 3. 5 comma negative 3. And this is what asymptotes. So we know that this piece gets closer and closer to this vertical asymptotes on this side. Then maybe you can evaluate it. So that's 5, 6, 7, 8, maybe 2. So this is a 4. Let's evaluate 8. Let's just evaluate 8 one more. F of 8. F of 8 equals 3 over 4 minus 8, which is a negative 3 over 8. So 3 over 8 is this much, negative 3 over 8 is somewhere here. So 8, so we know, so we can graph this side. This side of graph looks like this, because we have those two asymptotes, right? This is the asymptote, so this, so graph of this side will go to getting closer and closer to x-axis. This is getting closer and closer to this vertical asymptotes of x equals 4. So I have these two pieces.